how this biotransformation occurs. It usually happens in two different sets of reactions. One is phase 1 reaction and another is phase 2 reaction. In phase 1 reaction, what usually the drugs can undergo directly phase 1 reaction, or the usual mechanism is drugs will undergo phase 1 followed by phase 2, or it can be drug can also only undergo phase 2 reaction, or it can be the reverse case, drug will undergo phase 2 first, later phase 1 reaction. So what happens in phase 1 reaction? Here you introduce a reactive group, and after introducing this reactive group, the product of phase 2 reaction will be a reactive product. This product can be active, toxic, carcinogenic, or it can be inactive also. So consider this example. This is the structure of aspirin. What we did, we added a reactive group. So after phase 1 reaction, we have added a reactive group. This is the reactive group which we have added. So this reactive group, after phase 2 reaction, what will happen? Instead of this reactive group, we will add a bigger molecule at that place, like for example glucuronide. So this is glucuronide conjugation. In phase 1 what happened? There is hydrolysis of aspirin, and in phase 2 there is glucuronide conjugation. So in phase 2 you conjugate, for example it can be a glucuronyl group, and the resulting product after this conjugation, the resulting product will be what our biotransformation is meant for. It is inactive and polar, it will be excreted in urine. Now in phase 2 we conjugated a product, hence phase 2 reactions are also known as conjugation reaction. In phase 1 what happened? We added a reactive group, hence reactive group, or a functional group, hence phase 1 reactions are known as functionalization reactions. So phase 1 reaction we discuss hydrolysis, other examples can be, we discuss hydrolysis, there are other examples: oxidation, reduction, cyclization, decyclization. What is important is we have to remember all these reactions, because questions have been asked like all of the following are phase 1 reactions except, or the question can be which is the phase 1 among the following options. So if you, this is not very difficult to memorize. If you see, there are very small changes, like here you are adding oxygen, here you are removing oxygen. In hydrolysis adding water, in cyclization you are forming a bond, in decyclization you are removing a bond. So very small changes are happening. Whereas in conjugation you are adding a bigger molecule, and for example it can be a glucuronyl or sulfation, methylation, acetylation, or glutathione conjugation or glycine conjugation. Because you are adding a product and synthesizing a new thing, or synthesizing a stable thing, the phase 2 reactions are known as synthetic. Phase 2 reactions are known as synthetic reactions. Whereas phase 1 reaction, where you are forming an unstable product, are known as non-synthetic reactions. And these reactions, because this after this the product will be unstable, these are also known as catabolic. After this the product is stable, hence these are also known as anabolic. So this is very clear what is phase 1 reactions and phase 2 reactions. Now where do these occur? Both occur in liver, phase 1 as well as phase 2. Liver means not only liver, both can happen at other sites also, like plasma, intestine, kidney, etc. But most commonly and most importantly, and whatever is important for exam purpose, is liver. Where in liver, phase 1 reactions, most phase 1 reactions occur in microsomal enzymes. Microsomal enzymes, where they are located? They are located in smooth endoplasmic reticulum. And phase 2 reactions, where they occur? They are also occurring in liver. Where in liver? They are, most phase 2 are occurring in non-microsomal. Non-microsomal means they are located in cytoplasm and mitochondria of cell. Now, because I have said most, so there will be exception. All these are happening in microsomal except this hydrolysis. Hydrolysis occurs in non-microsomal. Hydrolysis occurs in non-microsomal fraction, non-microsomal enzymes, that is cytoplasm and mitochondria. And whereas, as here also I have said, most phase 2 there will be Most phase 2 is occurring in non-microsomal. There is one exception, and that exception is glucuronide. It happens in microsomal fraction. So clear. Hope it is clear. Now, why microsomal and non-microsomal differentiation is important? Because microsomal means these are inducible. Inducible means you can increase its activity, whereas non-microsomal are not inducible. But non-microsomal, you have genetic polymorphism. We have genetic polymorphism in non-microsomal enzyme. Genetic polymorphism means different individuals will be having different capacity to metabolize. For example, in acetylation, if we see, there will be some persons will be rapid acetylators. They will be acetylating drugs very rapidly, thereby metabolizing drug very rapidly and decreasing the drug's concentration and decreasing its effects. And there can be slow metabolizers, slow acetylators. We discussed fast, there can be slow acetylators. Slow acetylators means they will be acetylating drug very slowly, metabolizing very slowly, so that in such persons the drug accumulates and toxicity may result. So this genetic polymorphism is common in non-microsomal enzymes, and in microsomal enzymes these are inducible. And most important phase 1 reaction is this oxidation. Most important, and it is also most common, and most phase 1 reactions are mediated by cytochrome P450 enzymes. Cytochrome P450 enzyme mediate most phase 1 reactions, except for hydrolysis, which was occurring in non-microsomal fraction. Hence it is mediated by enzymes like amidases or esterases. Okay. What is important for us is only this oxidation. We have to focus on oxidation. Remaining is not important. I will finish off very quickly. Reduction is reverse of oxidation. Hydrolysis, I said it happens in non-microsomal fraction. Example, we discussed aspirin, and it is mediated by enzymes like amidases or esterases, etc. Cyclization. In cyclization, what we do? The linear structure is formed into circular structure. Example, proguanyl getting converted to cycloguanyl. Decyclization. Here reverse, the ring structure is getting converted to linear structure. Example, phenobarbital, phenytoin are having ring structures. So what I said important for us is oxidation. There are different types of oxidation reaction. For example, hydroxylation is a oxidation reaction. N or O dealkylation, oxidative deamination, or oxygenation at C, N or S atoms. So these are the various oxidative reactions. So in options, these can also be given option for phase 1 reaction. All of the following are phase 1. Option can be hydroxylation, hydrolysis. So don't get confused. Dealkylation, deamination. Okay.